Okay, welcome. Can you all hear me? Yes, it's okay. So, functional reactive Android with Groovy. Quite a mouthful. So let's see. The presentation will follow this structure. Why do we even need this? What does it solve, and how does it solve it? So my name is Carlos. I'm a senior Android developer at Muesli, an IoT startup. You should definitely check us out. This is my contacts. If you can read the code. If not, I will give you my handle at the end. So why do we need all these jargons? I would argue that there are tech reasons and human reasons. Let's start with the tech reasons. Some 50 years ago, Moore made an observation. It's called Moore's law, although it's an observation, that roughly the amount of transistors in a chip would double around 2 years. And 50 years later, it's still happening. And although you can see that the trends here start dipping, because we kind of are reaching the limits of how small we can make the transistors with the current technology. But if you see the graphic, it keeps rising. And why? Because we are increasing the number of cores. So we can't really make the current technology faster and smaller, but we can increase the number of cores that a CPU has. So parallelization is a big issue. And I would also argue that there are human reasons why we need this technology. It has been studied that our working memory, the one we are using to solve our problems, can only hold about 7 plus or minus 2 items. It's like your own CPU has 7 registers, which is not much, really. But there's something called chunking, which means that the piece of information that you put on one of those registers can be as complex as you want it to be, as long as you see it as a whole. So we need greater abstractions. And I would like you to read this great quote from Donald. The power of the unaided mind is highly overrated. Without external aids, memory, thought, and reasoning are all constrained. But human intelligence is highly flexible and adaptive, superb at inventing procedures and objects that overcome its own limits. So we are not really good at climbing trees, but we invent ladders and ropes. We are not good at surviving extreme weather, but we invent clothes. So we use this device in order to survive and to perform better. So why aren't we coding still in assembly? I would argue that anything that's being done today, I would be able to code it in assembly. Why aren't we doing this? Because if I'm iterating a collection, I don't really want to be dealing with registers. I want to have a for loop. And maybe if I'm dealing with a collection, I really don't want to be thinking about integers and that I have to increment the integers. Maybe I want to just say collection each and do something with a collection. So the languages have evolved to give you greater and greater abstractions. And we see this trend even with the hardware technology. So in the beginning, you will have the traditional IT where you would have to pick up your own machine, install the operating system, your frameworks and everything else. But then you don't want to deal with that. And you move to infrastructures as a service. So someone else manages machines and network, and you just have to install your operating system of choice and everything else. But maybe you don't want to keep updating security and patches and whatnot. So you move to platform as a service, and you just ask for, I want a database, I want some storage. Maybe you don't want to deal with that either, so you move to software as a service. You have an API that you can use. And the trend continues as X as a service, anything as a service. And you start to see this current, the latest trend, which is moving to microservices, where you just want to deploy a simple function that does what you want to do. And you abstract everything else. And as an example, a network of a deep learning system, a neural network that kind of models the way our brain works. You have the first layer where you just deal with like finding straight lines, diagonal lines, and then you build on that layer and you just start detecting like noses, faces, mouths, and then you build on that layer and you start detecting faces. So every layer builds on the layer before. So we need to go deeper. So what is functional? If you remember your second grade math, I can define a function x like just you pick up x and you add 2. That's a function. It's as simple as that. If you prefer the code version, that's the Java version, where you give it an int and you return that int plus 2. And we can make the following observations. This function does not keep state, and that's the most important thing. If it doesn't keep state for every input, for the same inputs, you always get the same output. And everything the function needs is provided as a parameter. And one thing that you should have also, it's that if you are giving as a parameter objects, they should, it's not mandatory, but they should be immutable. And you have an example of using the object integer. And I've written the same function using objects. And you can see that there's no set int on the integer object because it's immutable. And that allows for parallelization. Because if you have something that does not keep state, you can share it between multiple cores, multi-machines, and if you can break your problem into smaller pieces, you can give one piece to each core, to each machine, and you don't have shared state, so you make your problem, you can break down your problem and run on those multiple cores that we are seeing, because you cannot make the current ones faster, so you divide it to conquer. So making your code functional allows for the so-called parallelization. You can upload to those so-called microservices. I would argue that it increases the readability of the code, because if I look at a function name called add2, for example, and I see that there's only one parameter that's integer, and it returns an integer, maybe I don't need to see the inside of the code to figure out what it does. So when you provide everything as a parameter to the function, you can be, I would argue that it adds to the readability of the code. You don't have to check the code and to see that function is checking out other stuff in the operating system to make a computation. And it's language agnostic. You don't have to use Haskell or any of those functional languages. You can program functional in Java. You just use functions, even though they are inside objects. If you don't keep state in those objects, it's like you're doing functional. And then we move on to what's reactive. Basically, reactive, it reacts to events. And it's kind of the dual of having a pull system or having a push system. When you have a collection, you usually have an iterator, and the iterator has a hasNext method and the next method. So you have to check if the collection still has more elements, and if it answers true, you get the next element. That's pull. You are actively taking stuff out of the collection. The dual of the push, it's the observer pattern, where something happens and it calls upon you, also called the Hollywood pattern, as in don't call us, we'll call you. So you have, when something happens, it calls the onNext method on your object, on your observer. And when the collection finishes, you have the onComplete method called. And it makes it explicit that if some error happens during the process, it calls an onError method on your observer. Whereas in the iterator, you maybe get a runtime exception, or if you forget to call the onNext, maybe you get a null. It's not, it depends on the implementation. This one is made explicit. So how can we, why do we want reactive? As we will see in the following examples, it makes threading easy. So if you are having multiple cores, you should take advantage of them and use multiple threads. But having multiple threads, it's kind of hard, or to put it another way, it's easy to code it wrong. And you code something and it's working fine until you get a race condition, and you can't debug it, because when you start up the debugger, you won't catch the error. So it's easy to get wrong. You don't get the callback hell. So if you have multiple threads, you usually give it a callback so that when the thread finishes doing what it was doing, it calls your callback. And we have multiple, you have to manage how do we orchestrate all those callbacks. It allows for function composition. It has a ton of operators, as we see, and it's easier to reason about how you solve a problem. And this is important for us also. We can have a common vocabulary even between platforms. For example, we have an Android app, we have an iOS app, and we share the same ideas because they have another implementation of Rx. And we say, I say, for example, I solved this using the bounce and the flat map, and they have the same methods, so we can share a common language. So you're probably sick of me talking, so let's see some real stuff. So let's start with a really simple example. So the thing is, we want to print just the contents of the array. Observable has some convenience methods that it creates an observable, which is the thing that emits events from a simple list. So the Java version, you don't have array literals. You have to say arrays as list to create a list of ints. And then you subscribe, and for the subscription, you should give it an observer, which is one of these things. But as a convenience, you can give it a class which just implements the onNext element, the method. So basically, I'm just implementing the onNext method with this call. So it creates the observable and starts emitting immediately. And for each emission, the method gets called, and I print the the integer. It's kind of verbose with the Java up to 1.7. If you move on to Java 8, which is kind of almost available in Android, you've got lambdas and you can make it shorter. And I've put the Groovy version. I will just display it because the following examples are also in Groovy, so I just move ahead a little bit. So in if you see the Java 8 version, if the compiler can infer the type of the variable, you don't really need to specify the type. So you could omit the type. And in Groovy, if you omit the variable, by default it calls it. So you don't even have to declare the variable. Also, if you only have one parameter for a function, you can omit the parentheses. So you can see this as having parentheses here. So it's kind of more concise. Also, you have array literals, so the code is much shorter. I think you can understand what's over there. All right, so everyone's favorite network API library, retrofit. So let's look at an example. So a retrofit, you can give it a parameter with a callback, but it's already prepared to give you observables that wrap the object that you're trying to get from the network. So if I define in retrofit the function set user, I give it a path for the server and the parameter I'm trying to send, and it returns an observable that wraps your own object. So the way you use it, you call the API, give it the parameters, and let's just ignore the second line, the subscribe on, and you subscribe. This time, I'm giving it two functions. The first function is the onNext. It's the thing that gets called every time there's a new element. And the second function, it's the onError. So if an error happens in the network because you don't have connectivity or something, that's the method that gets called. So I promised that threading would be easier, and that's what's happening in the second line with the subscribe on. You just say subscribe on and specify a threading policy, let's say it that way, and I'm using schedulers IO, and it automatically runs in a new thread that's bound to IO type kind of operations. In the background, what it's actually doing, I think, is checking how many cores you have, and say you have 8 cores, it says, okay, so I can use like 7 threads because I still want to keep 1 core free. And that's being done for you. And as usual in Android, when you get back the results, a lot of times we have to put something on UI, and that thing has to run on the main thread. So it was running the background network in a call in a background thread, but then it has to publish the elements in the main thread. And you just have to say observe on Android scheduler's main thread, and that's it. You don't have to do anything else. And the interesting thing is that you can set everything up on your onCreate, the first 2 lines, these 2, and it's just when you do the subscribe that something happens. So you can use filters and do a bunch of operations. It's only when at the last step when you subscribe that you start the chain of events that runs the code. So let's see more examples. You can create, of course, your own observables, but chances are that most of are already created for you. And the RX Android library that we use on Android, it has some convenience methods, like we see here, the view observable text. Basically, you have a text edit, an edit field that emits strings every time you type something in it. And by using that method, it turns it into observable that emits the strings that the user is pressing. And so, with this example, what I'm doing is, basically, I have an adapter where you want to select at least 2 elements, and you have to have an edit box with a text field. And only when you have both conditions do I want to enable a button to move on to the next step. And so I'm using an operator called combine latest that merges 2 streams. One is the stream that's emitting the thing that the user is typing, and the one is the one that's emitting the number of items that the user has selected. So that it's 2 things that could be happening at the same time. And when I say combine latest, what it gives is just a function that combines both objects, and what I get, every time one of the streams emits an event, I get both. So if I type something, I get the new something and the old something from the other stream. If the other stream I select one more element, I get the last thing that the user typed and the number of things that the user has selected. And then I do a function and say that if both the length is over 0 and the number of things selected are over 2, do I want to enable the button? So you have, like I said, you have a ton of operators. I'm just showing some of the ones I use most to give you a taste of it. So in here we see another example. Basically, in this example, I have a map, and the user is scrolling the map, and the thing I want to do is get the address of the center of the map, the address of the center of the map. And for this, I have to make a network call that calls a Google service that gets me address for that location, latitude and longitude. But because the user is scrolling the map, I don't want to, for every pixel that it is scrolling, I don't want to be making a network call because it gets too slow. So the solution for this, for example, I use the bounce method. And what the bounce method does, it just says that wait until at least 500 milliseconds in the example have passed, and then give me the last element. So the user is scrolling the map, and it's giving me lots of positions that I'm just ignoring it. And when at least 500 milliseconds have passed since the last one, then I get an event. And then you have the usual subscribe on and observe on to deal with the Android background thread and main thread thing. And on the subscribe method, I set the text with the image, the address. More examples. If you're familiar with the Marshmallow permission model, now you ask, instead of when you install the app at the beginning, you have to give it all permissions. With Marshmallow, now you have to ask for the permission when you first need it. So that changed the code a lot. And there are some places where I have to check for the permission, and if I don't have it, I have to ask for it. And this example shows a place where I need the location. So I must first request the permission to access the location. And if I have permission to access the location, I have to check if the location is active. So I use a library called Rx permissions. And if you see the example, I request the permission. But in Android, you might request the permission almost any place, in a view, in a fragment, or in an activity. But you have to handle the permission response. You have to override the method in the class. So it's not really composable. So it's like you fire an event and then you have to wait for it to happen. And what this makes is it allows me to streamline the sequence of events, like checking if I need the permission, and if I need the permission, I want to check if location is really active. So I request the permission, and it's clever how he does this, because if you don't have the permission, a pop-up has to start, and you have to allow for location. And how he does it is that he launches a transparent activity that handles the dialog, and when it finishes, it gets the results of the permission call and hands it back to the subscriber. So in this example, I request the permission, then I filter it, which means I only want to run the following code if the permission was granted. So the part that you see in the flat map doesn't get run if the permission isn't granted. And for simplification, you can see look at flat map as a way of saying, and then run this. So I request a permission, I filter it only if the permission was granted, then I run the other code, and only if that code is run, the print line gets run. So a lot of things is happening with activities going back and forth, and network calls, and you get to write this in half a dozen lines. So there's other projects that you should be aware of. Our ExMarvels is a website that allows it to see the RX operators in action. I'll show you it in a few minutes. For the purpose of the demo, I have omitted some things that you should be aware, which is, let me show you. Okay, let's just see this example. When you subscribe to something, you give it an observer. Actually, that's not exactly accurate. You give it a subscriber. A subscriber is something that implements observer, but also has an unsubscribe method. And the thing is that what you should be doing in regards to the Android lifecycle is that when you stop the activity, you should unsubscribe from that subscription in order not to leak your activity. So the subscribe returns an object that you should keep, and the on your on pause or stop or destroy, whatever you're using, you should unsubscribe for it. And if you're dealing a lot with this subscribe and subscribe life cycle and fragments and that kind of stuff, you should check the RX life cycle. That makes it easy, and you don't have to worry when you have to subscribe and unsubscribe things. RxBuzz, it's not a real project, but you should check it out. It's an article. It's basically saying that you don't need an event buzz anymore because you can implement the same thing with Rx in half a dozen lines also. And the thing that we use a lot also in our project is Android reactive location. because it makes it really easy to deal with location updates when they happen, in which threads. It's another worthwhile project that you should check. So we're moving to Groovy. I'll just give a quick introduction why I find it interesting and compelling. So I gave it a shot a couple of months ago with just a class, and it started growing, and I'm nothing of going back anymore. So Groovy is a JVM language. It was born in 2003, so it's from this millennium. It's inspired by a lot of language. I would argue it's closer to Ruby in some aspects. It's a kind of superset of Java, which means that if you pick up a Java file and you rename it to .groovy, 95% of the times it will compile as valid Groovy code. So it's really easy to start because every valid Java code is valid Groovy code, almost. It has an Apache license now. It was previously sponsored by another company, but now it's under Apache, which might be a good thing for Google dealing with licenses and stuff. It was built to be dynamic from the start, so a lot of things only get run only at runtime. So you could, in theory, get errors at runtime that you could have solved at compile time. But a couple of years ago, every class that I use in Groovy in Android, it gets statically compiled. You just have to add an annotation. And since I'm adding that notation in every Groovy class, I made it a part of the template. I don't think about it anymore. It's just new class Groovy, and it already has the compile static on top of it. So why Groovy? You might know that you're already using it for the build system, although it's a DSL. It's built upon Groovy. JetBrains is pushing for a Kotlin implementation, so we'll have to see that in the future. But they themselves say that Groovy isn't going away anytime soon. Like I said, it looks like Java. It's easier to transition to, so you can start experimenting with it and start using everything you already know from Java. If you don't want to know how it's done in Groovy, and softly start using the Groovy way of doing things. It's much less verbose, we've seen. We have array and map literals. We have real closures that Java doesn't implement. It has anonymous classes, but it's not quite the same thing. We have null safe navigation, which we will see in a moment. It's more functional. It has a ton of functional methods, so it helps what I was saying previously, and the Apache license. So I've gathered a lot of things in this example. I'm building an alert dialog, which you might know in Android. So things that are different from Java. You see that we have the triple quotes, which is saying just I'm going to write a multi-line string that you don't have in Java. So you start with triple quotes, and you finish with triple quotes, and you can have the string spanning multiple lines. You have string interpolation. So when you see this dollar $workers, for example, or year, it's actually looking into your environment for a variable called that and using it to render the text. You can see an example of null navigation, because if this category were to be null, when I'm calling to uppercase, I would get a null pointer. And if I just add the question mark before accessing a method, I'm saying it's okay to be null. The thing that was to be run doesn't get run, and I get a null back. And when I'm interpolating strings, a null renders to an empty space, or no space at all, actually. So it's, and another thing, I mentioned the closures where it's looking into your variables, and you can see a closure coercion here, where we are giving it basically a closure or a lambda, if you want to think it that way, and coercing it to an on-click dialog or whatever. So the code gets a lot more concise. You've got switch on steroids. Instead of just using ints, and now you can use strings in switch, you can actually use classes or types of classes in the cases. You could use a closure expression that gets evaluated to true or not to evaluate a case, and you can return functions as results. Just a word, you see the return action as closure. This is kind of typecasting, but it's more advanced because you can cast it to other objects that are not castable. So, for example, I think I have an example. Yeah. So in this first example, I'm showing safe null navigation and Boolean coercion. What do I mean? So if my object is null, by using the question bar before accessing my inner collection, I don't get a null pointer exception. I just get null for the whole expression. And a null evaluates to false. So I can just use that expression in an if statement. Also, if I use that collection on purpose, other things that evaluate to false are called empty collections. So you can use an empty collection directly, and that code would only run if that collection was different from null and add elements. And you can get really creative and concise, and I'm showing that. So in the following line, if groups weren't null, it wouldn't execute the each method. If it's different from null, it will execute. Then I'm naming the variable instead of just saying it. So for each group, I'm doing something. So I'm checking another variable that's not here in an example, but I'm finding in that collection an item that has the same group parent, and it's really concise. And if I find it, so see the question mark, and if it has children, then I add it. So the amount of code I would have to write to check for nulls if I were doing this in Java would spawn 2 or 3 pages, I guess. So you get to express your ideas in a really concise way. You have a ton of AST abstract syntax tree transformations that you use with annotations. And you can think of it like compile time metaprogramming. And here are just some examples. So I mentioned compile static, which is just saying I want to compile this statically, like Java. If you have done any, created your own views, you know that you usually on Android you have to implement at least one of the. And if you just say inherit constructors, it does it for you. You don't have to do boilerplate code. Also, a lot of times, when you have an object, you want to have an equals, and you have to have a reasonable hash code for it, and you don't have to deal with it. You just have to say, annotate with equals hash code, and it does it for you. It checks all your fields and methods, and it builds a reasonable hash code from it. Also, if you annotate with toString, it does a reasonable toString by getting all your fields and methods. Also, you have annotations for making your objects immutable, so it builds tuples and you don't have to do much. You also have operation overloading, which the Java guys denied us from that C#, C++ had. They thought it wasn't a good idea. The Groovy brings it back, so you can implement your own operating overloading. So, tons and tons more. And this is just some of the things that I've used most. You have like querying operations and a lot of functional style things that you can do with Groovy. Is it all sunshine and rainbows on Android? Not really, but it's worthwhile. Sometimes when I'm debugging Groovy code, the debugger gets all messed up. The code is still running, but the debugger isn't showing me the correct lines. It's jumping all over. It's completely lost. If you write some inner classes in your Groovy code, sometimes the compiler doesn't like it. I haven't quite figured out why. The Groovy compiler does compile your Java classes also, and it has no problem with those. And in my setup, I have Groovy compiling everything, even the Java code. So it could be that if you're using libraries like Java preprocessors, they might not work. But I'm using Dagger, for example, an injection dependency framework that you should know and use, and it works just fine. And that kind of concludes my presentation. I think we still have a couple of minutes for questions, so if I am able to answer something, be my guest. Was I moving too fast? No? How many Android developers in the audience? Let me see a show of hands. Okay. Anyone using other languages like Kotlin or something else? No? Just straight Java. Okay. Okay, Thank you.